Hi there, everyone. My name is Michael Horowitz, CoderZ's Marketing Campaigns Manager at Intelitech. I'm very happy to welcome you to How Can We Enable More Children to Experience Learning with Robots? Our speaker will be Gary Garber. Gary has been teaching physics and leading robotics teams at Boston University Academy for many years and is a passionate advocate of robots in the classroom. For those of you who are not yet familiar with us, Intelitech has been a pioneer of robotics in education for more than 30 years. One of our latest innovations, CoderZ, is an online learning environment that allows students worldwide to program virtual robots using 3D engaging simulations while meeting key STEM curriculum goals. CoderZ makes robotics for education accessible, affordable, and enjoyable for all, and it is fully compatible with the LEGO Mindstorms EV3. You can learn more about the CoderZ's online learning environment by visiting gocoderz.com or by following CoderZ on Facebook and Twitter. Now, a few technicalities before we begin. We will be recording this session and we'll share it with you and with the other registrants at the end of the session. We welcome your questions. To submit a question, simply type it in the question box in the lower corner of the GoToWebinar control panel or tweet it using the hashtag STEMinars. Gary will answer your questions at the end of the session. As we mentioned, you are very welcome to tweet about this online workshop using the hashtag STEMinar and mentioning GoCoderZ during and after the webinar. Okay, let's get this webinar started. Gary, the audience is all yours.
Great, well, thank you. My name is Gary Garber. Good afternoon. I teach physics and engineering robotics at Boston University Academy. Just a little background, I've done dozens of workshops in computer science, technology, robotics, physics, and more. And I'm also the coach for the Boston University robotics team. And we've been doing FIRST Robotics for close to 20 years now. We've been doing VEX Robotics, VEX IQ, and FIRST LEGO League. Our team regularly hosts tournaments and workshops, and I have 2 books out there on LEGO EV3 Mindstorms. So, if you're new to robotics or you've been doing it for a while, why would you do robotics? Well, robotics are cool. Robotics really gets kids excited. And yeah, you know, the 1% of kids who are going to be interested in science no matter what, you know, they're going to be doing things. But what about that other 99%? How do we get them excited about science and engineering? Robots is the key. And building robots are in movies. That's what makes it really cool. Not only that, but with robotics, you can always make a game out of it. So much of our society is geared around sports. Well, there are all these robotics competitions, but even in your own classroom, you can make things into a competition and gamify whatever you're doing with robots. There's a huge diverse set of skills, whether it's building and putting things together with metal or with Legos, or maybe you're talking about electronics, or maybe we're talking about coding and writing computer programs. And what's nice is robotics really applies for a wide range of students. There's a huge range of entry levels, whether we're talking about the mechanical things or whether we're talking about basic coding. A lot of robotics things can be self-taught, or you can do things in groups. So there's so many cool things that allow us to really open up robotics to the other 99%. Robotics is really great for STEM education. A lot of what we have here is, yeah, you could do robotics as an individual student, and you can make great robots. But what's really I like about robotics is it's great for getting kids to work together. And when you're working on bigger robots, you can really emphasize the teamwork. All right, how are we going to work together and make a really big thing? And these robots can solve problems. So for its critical thinking and problem solving, these are all great tasks that you can teach with robotics. You can allow the kids to be creative. What can they build that's new? You pose a problem for them. It's an open-ended problem. What kind of solutions can they come up with to solve that problem? And maybe one kid comes up with a solution, and other kids will see that solution and innovate on it and design something new. one of the important things that we're doing as kids work through these projects is to get them to document their work and to really think computationally. So these are all great 21st century skills that we want kids to be involved in. But what are some of the challenges to doing a robotics program? One of the main things is money. Robotics can be expensive. For $300 or $400 a kit, how are you going to get one kit for every 2 or 3 or 4 students? Or do the kids know enough to get involved in robotics? Do the kids all have the same knowledge? Or what do you as the teacher know? Do you know enough, or do you need to know more in order to do this? What if you don't have many materials? What if you don't have space for a full program? What if you don't have the tools? What if you don't have a full machine shop? Is it dangerous to build these big, huge robots? So these are all huge concerns for making a big robotics program. But there's some pretty easy solutions, and one of them is taking the virtual route. Now, by virtual route, we mean a simulation of robotics. And whether you're doing, physical robots or virtual robots, coding and simulations are going to be important. Why emphasize coding? Codings are needed across disciplines. It's just not for computer science. When I take kids on lab tours and bring them to biology labs or to physics labs or to chemistry labs, and I try to get kids interested in working in a lab for the summer, one of the first questions that professors ask is, can you code? The professors and engineers, they have enough assistants who can run a pipette or put 2 things together. They want kids who can run the simulation, write code to analyze the data and visualize the data. So in a lot of industries, they really need kids who can code and run experiments of this, run simulations of the experimental work that the scientists are doing. And you've probably heard the phrase that most of the jobs that will exist in 20 years haven't been invented yet. And indeed, having a background in computer science will be so important. So if you're going to do a virtual robotics program, the thing that's emphasized most is the coding. Other thing, what do we mean by virtual robotics? And that's what CoderZ is all about. And I'll share that with you in just a few moments. But really, it's a computer simulation and emphasizing it. What's nice about it is if you want to make changes in a physical robot, it can take time. You have to change your code, then you have to download your code, and then you have to run things. What's nice about a virtual program is you might still want the hardware, but you could have 1 set or 2 sets of hardware for your entire class, and every kid could be running simulations with new code, and then they can take turns downloading the hardware. If you only have a limited amount of hardware, the kids all have to wait in line to test out their code. But if you have computer simulations, each group of kids that has their own Chromebook or tablet or computer in front of them can be testing out their code. Now, I mentioned hardware. And what does that have to do with CoderZ? So CoderZ is basically a learning environment that's web-based. So you access it through the web. There's no software that you need to install. And kids will write all the code themselves. And then they can run this code, and they see the results immediately using this computer simulation. So it allows them to change the code rapidly. So instead of downloading the code and waiting 10 seconds for it to download, boom, they just run the simulation and instantly they can see what's happening. And so it allows them to really get into that iterative design process. So they see what's happening on their screen and they can make changes. And it allows kids to take risks. One nice thing about seeing what's happening on their screen is the entire class doesn't see it immediately. So they can test out their code in private or in their small group of 2 or 3 students. And they're not afraid of trying things and risking and failing forward. Because if they don't take risks, if they don't have the courage to make mistakes, they're never going to make progress. And we want the kids to be able to make mistakes, to learn from their mistakes. Other nice thing about CoderZ is it allows programs to be gamified and have competitions. In fact, there's a CoderZ competition going on right now to try and make games using the CoderZ simulation, which I'll show you in a few moments. One of the best things about CoderZ is the CoderZ simulated robot is the Lego EV3 basic robot. And so they can download their code onto an actual real EV3 Mindstorm. And what's going around their screen is an EV3 robot. On the screen, just like the real EV3 robot, there are sensors, and there's a heads-up display that displays values for all those sensors, for the touch sensor, the gyro sensor, what direction is the robot going, the color sensor, what color, or is there a line tracker beneath the robot. There's an ultrasonic sensor that tells us the distance of things. There's encoders that tell us how far the wheels have turned. So location, how far we've gone, orientation, these are all things that the sensors on the simulated robot will tell us, just like a real Lego EV3 robot. What's really cool about the CoderZ robot is it has a simulated physics engine. In other words, it's just not a video game moving around the screen. The motions of the robot are based on reality. So in other words, there's sensor sensitivity. As the light sensor passes from a light to a dark region, it's not just going from a signal of 0 to 1, there's an intermediate region. It's going to sense different light levels. There's going to be friction as the robot rubs up against the wall. The robot's not going to stop on a dime, a real robot, and the same with our simulated robot. It's going to have momentum. So once you program it to stop, it's going to have some inertia. It's going to take a couple seconds to stop, just like a real EV3 robot. So a lot of physics went into designing this robot. Now, the main thing that kids will be using is a language called Blockly. And what happens is kids will drag blocks onto the screen from several different categories. And they might be control flow categories, they might be sensor categories. And what's cool is kids with no programming experience whatsoever can drag blocks onto the screen and from day one start writing programs. Because they don't need to type things and have a bunch of things in their background to know already. It's just as simple as dragging things onto the screen. And so we can see in this program here, they've written a simple little program with some loops and some constants and some variables and some sensors in it. Now, you're not limited to that. So you're not limited to Blockly. What CoderZ does is there's an option where the kids can see whatever they've written in blocks and instantly see the Java code behind it. So this Blockly code, the blocks get converted into Java, and then that Java gets downloaded onto your Lego robot. What's also cool is if for your more advanced students, if they want to program directly in Java, they can do that. Now, the simulation, just to show you what the simulation looks like, let's take a look. So here's our robot, and what it looks like is this. And so we can see the robot moving around. And you can pan with the robot. You can zoom in. You can have a first-person view. What does it look like from the point of view of the robot? You can even put a pen down on the screen and see where the robot has gone. There's even an option, kind of a joystick control, to control the simulated robot. So instantly they can see what their code is. And you can see in this example, the robot was trying to drive in the path of a triangle. You can choose which sensors and motors will be on your robot. So you can configure your robot for many different things. There are several different simulated environments to choose from. You have an open space, or you might have a parking lot. Can you park the car? Can you track a line? Or there are more interesting environments. You might have certain line tracking challenges. And you can see in these two images, we have a robot that's going to try and track these lines. There might be games where they're trying to pick up some bolts, or pop a balloon, or avoid an obstacle on the line. It's one thing to track a line, but to track a line and then have to divert off the line to avoid a stick of dynamite, that is a challenge. There might be gamified versions where you're trying to pick up bolts and nuts, and you get points for that, just like in a real game. Or use your sensors. For instance, all right, program the robot to turn when it gets to a wall. Or make your way through a maze. Maybe you're going to track a line through a maze, or maybe you use the gyro sensor for making a 90-degree turn, or the ultrasonic sensor to turn when you get a little bit away from a wall, or to sense if you're in a maze, which way should you go? Should you turn left or should you turn right? Can you make the same code that will get through a maze that you've never seen before? And again, that's where the coding gets really advanced. A search and rescue type game, where somewhere in this field of nuts and bolts is the prize. And it's in a different location each time. So the kids have to write a search and rescue algorithm to try and find the target, and who can complete it in the least amount of time. So there is the CoderZ platform, which is great, and there's also a curriculum that's been standard matched that goes along with it. So it's a 9-week curriculum, 45 hours of in-class programming that the kids can use, starting out with introductions. From day one, the kids will take programs that they're presented with, and they have to debug it and learn what to do. And then they'll be writing programs with loops and sensors and driving around using variables. By the second half of the course, they'll be using proportional controllers and color sensors. And by the end of the course, they'll be using probability and statistics to try and make their way through a maze. There's a lot of computer science topics that will be treated. Sequences, loops, switches, variables, counting and indices, mathematical operations, Boolean logic, true, false, proportional controls, gain, set point. So a lot of the basic computer science topics are there, and these have all been matched to standards. There's a lot of math involved in the curriculum. Basic calculations, some basic algebra, a lot of geometry, the area of rectangles, perimeter, area and perimeter of circles, how to find the area and perimeter of a polygon, driving, coding your robot to drive in a polygon, finding ratios, probability. When you go through the curriculum, there'll be a lot of informational slides. So kids will learn things. All right, what is a loop? So you as a teacher don't need to be a master of it. The kids will learn this at their own pace. So they will go through this at their own pace. They'll be presented to programs to debug and modify a program. When they start out, they'll be given something. All right, we want that robot to drive in a square. Change these parameters in order to get your robot to drive in a perfect square. Let's say the kids write a program and it's not working. The curriculum has diagnostic wizards to help them figure out what is wrong with their program. There'll be lots of great common practices that you'll see in computer science that are used, such as emphasizing the kids to add comments to their code so others can understand it. The use of pseudocode. So in other words, before they just jump in and start programming, to start thinking in English, what is the order of commands that they want to happen? What is going to happen to their robot first? Should it drive straight, go back to the beginning, test to see if they've gone 4 sides? So again, an emphasis on pseudocode, or what's called plain language code. There'll be examples where the kids are given code, they see some pictures of it, and they have to drag the blocks onto the screen and do it themselves. And again, that's kind of at the beginning, or if they're doing something very complex, before they get to those more complex things. Because we want to get the kids up and running and coding as quickly as possible. Throughout the curriculum, there's checkpoints and questions and small quizzes throughout it. And it'll tell them whether they're right or wrong, or do they need to change their thinking on something. There'll be screens where they have to go through sequences of commands and loops. To give you an idea, towards the end of the curriculum, they'll be developing proportional line trackers. The kids will be using variables, ideas such as set point and gain, which are really advanced computer science topics. And the kids will be using nested arithmetic operations, as you can see in the screen. The kids will be integrating with sensors. So the CoderZ curriculum, it's an awesome curriculum. The kids will have a lot of fun. They'll be learning computer science and math, and there's a great robotics connections with things. And they'll get to download whatever they've done onto hardware. So again, I think when I'm doing robotics with kids, one of the frustrating things is if the kids are waiting in line to try and test their things out. But with the simulations, there's no waiting. They can test things out on their screen, and then they can take turns working with the hardware. So it really is, how do you run that class so the kids aren't spinning their thumbs waiting to have access to the one piece of equipment? So when I do robotics in my classroom, I do a lot of simulations. So I like it. So at this point, I want to thank everyone for attending and see what kind of questions we have.
Thank you, Gary, for a really wonderful presentation. We have a few questions from the audience, and hopefully people will send in more as we're answering these. So I wanted to start off with a question we received from Gabriella. Her question is as follows. There are so many online tools to teach coding now. How should you choose between them?
And a lot of it, what it is, and there are a lot of things out there, and you're going to have to find what fits for you. And some of the things, again, what's your budget? What's your space? Do you want robots involved with the coding? And like as I said before, the one reason to involve robots is it's fun. It gets the kids excited. There's a lot of things like Scratch, and you can just get kids involved in coding and making their own video games. But what I like about robotics is usually you can do the coding and then downloading it onto hardware and seeing the actual things move around. I will say I'm a huge proponent of what's called the visual programming. And in CoderZ, you saw the Blockly as a visual programming. There are lots of different things. The Lego Mindstorms itself has its own visual programming language. So if you have kids who are just jumping in, working, it's always good to start out with that kind of visual programming language, whether it's Blockly or Scratch or the Lego Mindstorms language. Doing something visual really lowers that entry barrier. So, things to look for are, do you have a low entry level that's accessible to all students? But then, what's the ceiling? So can you find something where, how advanced can you get with it? Can you do variables? So can you get advanced with whatever you're doing? Other things to think about is, what kind of platform are you getting on? Are you using Macs? Are you using laptops? Are you using Chromebooks? And for whatever language you are, is it web-based or is it software-based? And how are you going to access? So those are important things. And try things out. Don't just jump in. Try something for a week, then try something else for a week, and see what works well for you. Whether you're going to go with the web-based or the software-based things. Some things, again, if it's a netbook or a Chromebook, that might be a big advantage. Again, depending on your budget. One thing to think about with hardware, particularly with laptops, you might have like a 3 or 4 or 5 year lifespan for that hardware, and the computers might be your biggest expense. How can you reduce those expenses? If you're dealing with hardware, do you need a machine shop? Are you dealing with metal robots? Are you dealing with Lego robots? So again, those are a lot of the things that you'll have to decide based on your individual situation.
Thank you, Gary. And actually, I want to mention here that you mentioned trying out software before committing to it, and CoderZ actually happens to have a free trial, so definitely check it out. Okay. So we have a few questions actually that fit into a theme here. I'm going to put them together regarding age. We have a question from Lori. Are you using CoderZ with college students? And from Doug, is there an age range assumed for this? And then actually from Don, we have what age group is ideal for CoderZ? So we have a lot of age questions.
Yeah, so that's great. So I'll address Lego robots first. So, and I have used Lego robots with kids in 1st and 2nd grade, and I have used Lego robots with college students. And I'm a teacher partner over at Tufts University at the Center for Engineering and Education Outreach, and they use Lego robots in their undergraduate computer science classes. And they're probably using LabVIEW as the coding language in those classes. But indeed, you will see um, of visual programming used for undergraduates to do coding. And you might think undergraduates, they're only going to jump in and do the line code. But you will see visual programming used even with undergraduates. Having said that, one thing that's nice kind of on that age range for particularly for CoderZ is with the younger kids, you might jump in straight with the Blockly code. But when you start up a CoderZ program, you have a choice. And the choice is, do you want to go with Blockly for your initial coding, or do you want to jump straight into Java? And if it's an undergraduate class or maybe a high school class, you might want to jump straight into the Java, depending, again, on the skill level and experience of those students. If they've never done any programming before, they might want to jump into the Blockly anyways, so they're a bit more comfortable with it. If it's an undergraduate computer science class, they might want to jump straight into the Java programming. So that gives you a sense. And really, and when we're talking with the younger kids, you can get some advanced stuff with that. So when we're talking with younger kids, and with the second, the third, the fourth graders, sequence of commands, do A, then do B, then do C. Get into the advanced stuff like the loops. When you're talking about older kids, middle school kids, and I mentioned kind of a buzzword before, which I didn't define, called the proportional line controller. And that's more of an advanced topic, which is what you get into with those middle school kids and those high school kids. And what the heck is a proportional line controller? Most of us have either driven in a car or been in a car that comes to a stop sign. And we've all been with a bad driver who drives as fast as they can towards the stop sign, and then, maybe about 10 feet before the stop sign, slams on the brakes. And you could code your robot to do that. You see the stop sign or you see the line, and your robot slams in the brakes. And that's kind of a very younger way to code. But then when the students get older, for a real stop sign, you'll probably start to gently push on the brakes as if there's an egg underneath your brake pad as you approach the stop sign, and then slow down gradually as you get to the stop sign. Coding a robot to do that is a challenge. It's actually difficult. And so that's more of an advanced thing. It takes a little bit of algebra. And so that's the kind of thing that you would get into with middle school kids or high school kids or college kids. When you get into the older kids, you'll think about those things graphically. All right, what is the slope of the line? How are we going to optimize our approach to get to that stop sign as quickly as possible and stop a set distance before the wall? But believe it or not, this idea of a proportional controller, I've done it with third and fourth graders. They don't understand all the details. But when you get to the older kids, then you get into the algebra. When you get into the even older kids, then you'll look at the calculus-based version of it. So really, when you get into variables and arithmetic and looking at some of these more advanced things, really, there's an entire range of abilities. The curriculum itself that goes with CoderZ is designed for middle school kids, but the CoderZ platform, again, you could use that for a huge, wide range of ages. I'll stop there. I probably forgot something that I was asked, but.
No, that was good. That was fantastic. I think that answered the question. And moving on to something you just touched actually on, is it necessary to have a set of EV3 hardware to be successful with CoderZ?
So you don't need it at all. You could do everything virtually. So one thing might be, hey, do you have money for an EV3 set? Do you have space? You might have small little desks and nowhere to put an EV3 together. So you could do everything virtually, and there are dozens of different simulated worlds to drive your virtual robots. So it's not like you're just going to drive through this one parking lot and the kids will get bored. There are dozens of different virtual worlds that the Lego robots can drive through. In fact, if you're doing hardware, your Lego robot might be limited to your classroom. But with the virtual world, you might have your Lego robot driving around the moon or different kinds of mazes. If you want a maze for your Lego robot, you need to get out the 2x4s and a saw and build a maze for your your physical Lego robot to drive through. In the virtual world, you just click, 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 and boom, you've got 3 different mazes to choose from. In fact, the kids will get a different maze each time they run the program. So you don't need it. Now, having said that, you've probably all seen some classrooms where they've got 20 Lego sets in their classroom. You don't need 20 Lego sets. Maybe you've got just 1 Lego set, but at least you have 1 piece of hardware to download things onto.
Thank you. I think that answers the question. And now moving over to the coding side of things, I have 2 questions. I'm going to put them together to try and get to all the questions here. One question was from Peril. How does the block type language transfer to actual coding for the kids? And then from Jackie, can the students see the code behind Blockly? So I lumped those 2 together.
And so they can do that in pretty close to real time. There's a new pane that can open up. And actually, why don't I go back to the beginning? Sorry to scroll through like this, but let's go to right here. Right here. And so this could be in real time where you, although I did, for this image, I cut and pasted 2 things that were on my screen at the same time. Actually, these weren't on the same screen. But basically, you can view, as you drag the blocks onto the screen, it creates the Java code. Now, the form of Java, what you may or may not be familiar, is called Legos. And L-E-J-O-S is Lego Java Operating System. And so it's a form of Java that's made specifically for Lego robots. And so there's a few commands that are unique for the Lego robot platform. And then what happens is, so you drag the blocks onto the screen in real time. As soon as you put the blocks on, it changes. And one thing is, I'm not sure if the arrow can be seen, but you can see in purple there's some parameters here, all right? And you can see there's a delay of 2000. And then over on the Java side of the code, you can see we've got the number 2000 right here. And this 2000 is, if I change my parameter over here on the block, it will almost in real time, slight delay. But as soon as I change my number, it changes in my Java code over here. Whoops, it changes in my Java code also. You can see the drive power of 100, and over here we can see the drive power of 100. And then what happens is the Java code, if you want to download it to the physical hardware, it puts it into a machine code when it downloads it to the actual Lego hardware.
Thanks. So I think that answers both questions because they are using the Blockly, and then because the Java is right there, they can transition easily over to the Java.
Yeah, it's also a good stepping stone for learning Java, because, and actually it's a couple lessons in the middle school curriculum that we have. The final couple lessons is try to match. Look at your Blockly code and try to match the appropriate statements in Java. So there's a couple exercises at the end of the course to try and get them hooked on that next level.
Fantastic. Okay, so let's see what the next question is. We have a question from Carolina. If you work with the hardware EV3, it gives all the group members a chance to participate in the construction and programming. How does CoderZ fit into teamwork?
Yeah, so teamwork and collaboration is a big thing. And again, that's a big approach. And it's more of a teaching style than specific to any one software package that's out there. And yeah, you might have, let's say, some kids who build the robot and some kids who code the robot. And and when you have a larger robotics team, let's say a first Lego League team, you're going to have a couple kids working on a project and a couple kids building and a couple kids coding. And that is one way to organize things. And so that is one way to get kids to work together. And if you have a robotics team, that might be one way of doing things. In my classroom, how I do things is a problem is posed. And then you tell kids, all right, come up with a solution document your solution. And then what you want kids is to come up with a solution to the problem and then to share it. And so each kid will come up with a different solution, and then they share their solutions, and then you have them go back and revise their solution and innovate and make things better. And so really getting kids not to think in a small bubble, but to compare how they're going about solving a problem and then trying to get better at that solution. And again, comparing what they're doing to others. And so that's really a big piece of the puzzle.
Thanks. So now we have a question that I think I can actually handle. And the question is from Don. The kids in my program compete in First Tech Challenge. How is CoderZ integrated into or compatible with FTC? So I can tell you, Don, that the version that Gary is presenting is compatible with the Lego EV3. However, we do have another version which is compatible with FTC. And if you want to get in touch with us, we can give you access to that also for a free trial. And that one is fully compatible with the FTC robot used in the competitions.
Yeah, the Tetrix robots used for FTC, I think it was a claw bot, I think, if I seem to remember. And so it's a basic, there's an arm, you can grab things, and you can drive around. But what's nice about the Tetrix version for CoderZ is there's an actual movable arm, and you can manipulate things.
Yep. So here's an interesting question. How do you get students using the CoderZ program to, I think he wrote to just copy the code of the student next to them, but I assume they meant to not copy the code of the student next to them. So I guess the question is, how do you stop people from just copying and not learning, just copying the person next to them?
Yeah, so there's a lot of ways of looking at that. And, you want kids to collaborate and work together. All right, so you want to encourage them to think about that. Having said that, one of the other buzzwords we're using nowadays is to gamify things. And if you're gamifying it, is a lot of these challenges is who can make it through the maze in the least amount of time? Who can pick up all the bolts and collect as many points in the least amount of time and get the highest score? So not all the challenges, but many of them have a gamified type score. And so, if they're competing against the others, then, needs to say they have an incentive perhaps to not share exactly what they're doing. So I will say I'm a big fan of collaboration, but there's certain times when if you gamify it, you'll make it a bit competitive too.
Fantastic. So we're getting close to the end of our time. We have a question from Miriam. Do you think virtual cyber robotics are a solution that can actually help students who cannot afford hardware develop 21st century skills? Why and how?
So yes, and it's awesome because one thing is maybe you have some equipment at school, all right, or the hardware at school, but the kids can get into the virtual simulations from anywhere that has a web browser. And so if they're at home, they might not have that Lego robot at home, but they can code at home if they have a tablet or a Chromebook or some kind of web-based thing. So they can do the coding at home, and they can run the simulations at home. So that kind of opens up a lot of doors. Or, do you have, one set of Lego robots for your entire school, and Class A is using it that day? Well, Class B can't use the Lego robots. But if you have the Chromebooks, hey, that makes it possible for more classes to get involved in the coding. So I think it really opens things up. And running the simulations, what do the kids do when they go home? They play on their Xbox. All right? They're used to a simulated world. They're used to playing Minecraft. They're used to making these simulations. And so we're really going into the medium that the kids are already comfortable with. I wish I could say more kids were comfortable with manipulatables and putting things together with their hands, which is an important skill. but kids are very comfortable with Minecraft and with video games and working in that visual world. But to get kids to code and to create those virtual worlds, that is going to open up doors for them.
Excellent. Okay, so if we don't have any more questions, we're going to wrap it up. Thank you, Gary, for a wonderful presentation. Enjoyed the discussion a lot. I think our audience did as well. To continue this great conversation, I recommend joining the Robotics and STEM for All Facebook group at facebook.com/groups/STEM4all, number 4. I also want to welcome Kathleen, who is in the audience. She's actually going to be our speaker at one of our upcoming sessions. Before we go, I wanted to tell you about a special promotion we are having. We are offering a heavily discounted classroom bundle, including the Coding Robots curriculum and 24 annual subscriptions to CoderZ for just $600. To take advantage of this special promotion, reach out to us for a quote. On behalf of the IntelliTech and the CoderZ team, I want to thank you all for joining us today and for your great participation. If you have any questions, please be in touch with us, and we will be more than happy to connect you to Gary. Have a wonderful day.